16 years old, I'm a sophomore in high school, and I created a new way to detect pancreatic, ovarian, and lung cancer that costs 3 cents and takes 5 minutes to run. Over 85% of all pancreatic cancers are diagnosed late, when someone has less than a 2% chance of survival, and our current methods are really outdated and just really bad. So I decided to try and create a new way to detect cancer. So in the next 10, 20, 30 years, my vision for medical diagnostics and cancer diagnostics would be first a shift from symptom-based diagnosis. So for example, say I'm coughing, then you would say, oh, he has a cold. And then we would shift to something that would specifically say, you have a cold. So for example, that's my test. And that's really going to be the future of medicine because you really want definitive, quantitative results that you can say, he definitely has the cold, or he definitely has the flu, or he definitely has pancreatic cancer, instead of our current general iffy condition for symptom-based diagnosis. The current blood test for pancreatic cancer is called ELISA, and essentially it takes a drop of blood and from that can look at different proteins and detect these different cancers. And the problem with it is that it costs $800 and is really grossly inaccurate, missing 30% of all pancreatic cancers. So overall, it's just a really crappy test. So essentially what I created is essentially like a paper test that you put a drop of blood on, and it will change its electrical properties based on the amount of this one protein, which signals the amount of pancreatic cancer that you have. When I emailed a bunch of professors to get into their lab, the entire medical community seemed against me and said that this project won't really work and this is a really bad idea and a 16-year-old could never come up with this. But one professor at Johns Hopkins University told me, yes, this might work, but it might not. So come into my lab and we'll see if your idea is valid. So my idea actually turned out to be amazingly valid. It actually has 100% accuracy so far in tests, but also it can detect the cancer in the earliest stages when someone has close to 100% chance of survival. And then also, because it only costs 3 cents and takes 5 minutes to run, it's 168 times faster, over 26,000 times less expensive, and over 400 times more sensitive than our current gold standards of detection. So what's so different about my technology is that it uses a lot of modern tech. So for example, carbon nanotubes, long thin pipes of carbon that are 1/50,000th the diameter of your hair, but also an ancient technology, antibodies, which essentially only react with one specific protein. So I was just saying in biology class, and I was like, maybe these two could be combined to detect different proteins. And so this differs from other methods just because it is a lot cheaper. It costs 3 cents, and then also it's a lot faster, taking 5 minutes to run, just because of the entire idea. It's just a complete divergence from the current ideas. So essentially what happens when you are doing the test, the sensor is made up of a network of carbon nanotubes. And essentially they're just these long thin pipes that are just like scattered around in this giant pile. And then you put antibodies in that, and that's a really simple procedure. So then you have this network that only reacts with one specific protein. And when that protein comes in contact with this network, actually physically it goes into that network and it will react with this antibody. So essentially it just smushes together and forms a larger molecule. And that when you do that, it rips apart the entire carbon nanotube network and makes it hard for electricity to flow. So what tells me that a test is positive is I'm actually using a $50 ohm meter that I snagged from my dad. So essentially what happens is based on the amount of change that you see in the electrical properties of the paper sensor, you can tell how much of one protein is in a person's bloodstream. And from that level, you can say they either have pancreatic cancer or they don't. This test could be found in every single doctor's office. In probably the next 10 years, you could have an entire array of different sensors, from my sensor with pancreatic, ovarian, and lung cancer to HIV, and then also heart disease. And they just have this array and be able to test you very quickly. That's what's so cool about my sensor is the fact that it's so versatile. It kind of serves as a platform to detect any disease. And so we would see, for example, pancreatic cancer survival rates jumping from 5.5% to 100% just because we're detecting it in the earliest stages. And so that's one of the really cool properties about how it's going to revolutionize medicine and also empower the patient to do testing at their own home.